So, what in the world does a muddy construction site have to do with high performance computing? Well, it turns out a lot more than you'd think. Today, we're going to break down how a company called 950 Wood is building what they call a digital refinery to connect these two very different worlds. When you picture cutting edge tech, you're probably thinking of a spotless clean room, right? Or maybe a massive data center. But this one starts right here. And the source documents don't pull any punches. They call it what it is: a dump. A resource recovery center in Hamilton, Ontario, surrounded by piles of demolition debris, busted up pallets, and old fence posts. And that right there, that's the big puzzle we're going to unpack. You've got this dirty, chaotic physical world on one hand. But on the other, the technical manual for what's happening here, it reads like it's for a biotech lab, full of talk about agentic workflows and multimodal AI. So how do you possibly connect those two realities? Well, you do it with this idea: a digital refinery. The concept is actually pretty simple, but man, is it powerful. You treat the messy construction wood not as trash, but as crude oil. It's this raw, unrefined input. And the refinery's job? To process that raw stuff and pump out something incredibly valuable: a certified, data-rich digital asset. Okay, so to really get why this is such a game changer, you've got to understand the problem they're solving. For ages, the construction and waste industries have been stuck in what the systems architect calls data anarchy. It's a world built on paper, guesswork, and just a totally broken chain of information. And this slide just nails the difference. The old way? It's all about liability. You've got handwritten tickets that disappear, contamination's a huge risk, and that pile of wood, it's just a cost, something you pay to get rid of. But the 905 Wood way, it completely flips the script. It uses technology to create a perfect, auditable digital record that turns that very same pile of wood from a liability into a valuable asset. Right, so how do they actually pull this off? The secret sauce is something called the sentient bridge. Think of it as a 5-layer tech stack that connects all that physical chaos to digital, perfect order. This is the engine of the whole refinery. Let's actually break this stack down. At the bottom, you've got the hardware. And get this, according to the tech report, they're using a future Google Pixel 10 Pro, but not as a phone. It's a tough-as-nails industrial computer right there on the site. Powering that is Google's custom Tensor G5 chip, which is crucial for running AI models directly on the device. Then a future Android OS would manage the whole workflow, while a specialized on-device AI does instant analysis. And finally, you bring in the big guns from the cloud, AI like Gemini and Claude, to handle complex regulations and automatically spit out the final compliance documents. And this shot, which is straight from that technical report, makes it super clear. This isn't your pocket-friendly consumer phone. They're using the Pixel 10 Pro as a distributed inference server, basically a mini supercomputer built for these really harsh environments. It crunches all that sensitive visual data right there on the edge, meaning at the muddy site itself, which keeps data private and ensures everything is fast, even in a network dead zone like a concrete basement. And that's what this is all about: being ready for industrial-level work. I mean, your normal phone would totally overheat in minutes doing this. But the Tensor G5 chip, it's built for an 8-hour continuous duty cycle. It's made to work a full shift without breaking a sweat, which is, absolutely essential on a real job site. Okay, so we've got the tech. We have the hardware, we have the software, but how does it all come together? How does a pile of muddy 2x4s actually turn into a verifiable digital certificate? It really boils down to 4 key stages. It all kicks off with a customer's request for quotation, or RFQ. Then we get to the really critical part: the on-site analysis at what they call the compliance gate. That's followed by a really clever verification loop, and then boom, the automated generation of the compliance document. Yeah, this idea of the compliance gate is where the magic really happens. The entire goal is to move characterization upstream. What does that mean? It means figuring out exactly what kind of wood you're dealing with right at the source before it gets tossed into a bin and mixed with who knows what else. This is where that on-device AI really shines. And it's got to be fast, seriously fast. Using that AI model right on the Tensor chip, it can tell the difference between clean and treated wood in under 2 seconds. That speed is everything for the user experience, right? Because if a truck driver has to sit around and wait, they're just not going to bother. But of course, the real world is messy. It's not a lab. So what happens when the AI gets confused? An AI model trained on perfect, dry lumber in the middle of July might totally get thrown for a loop when it sees that same wood wet, gray, and covered in snow come November. This problem? It's called data drift, and it's the #1 enemy of any real-world AI system. And this is where the system's design is just so smart. The AI doesn't just guess yes or no. It gives a confidence score. So if it's only, say, 55% sure, it knows it needs a second opinion. This automatically triggers a human-in-the-loop review. The tricky image gets flagged, a human expert makes the final call, and this is the beautiful part. That correction gets fed right back into the system to retrain the AI. The model literally learns from its own mistakes.
So after all that back and forth, all that verification, the system has everything it needs to create the final product. And that product isn't a pile of wood chips. It's a piece of data, an unbreakable, totally auditable digital chain of custody.
And here it is, the digital diversion certificate. Just look at the data packed in here. You've got the precise GPS coordinates from the job site. You have the AI-verified percentage of clean versus treated wood. You know the specific facility it's going to, and you have proof it was actually turned into biocarbon feedstock. It's a document that's automatically generated, completely audit-ready, and it makes following complex rules like Ontario Regulation 347 almost effortless. So, what's the big picture here? What's the massive payoff for all this incredible technology? Well, it's all about kickstarting a huge economic shift by creating a super reliable supply chain for Ontario's circular bioeconomy. You see, the industries that are going to use this stuff, we're talking advanced materials, green steel, they have unbelievably strict purity standards. They need contamination levels below 1%. There's just no way you can hit that target with handwritten notes and pure guesswork. You need the kind of precision that only a digital refinery can give you. And this chart, it just perfectly sums up the whole economic flip. On the left, you've got your standard construction waste. It's a negative value. It's a liability, something that costs you money to get rid of. Then, on the right, after it's gone through the digital refinery, you have verified feedstock, a positive value. Technology has literally turned a cost into an asset. So by building this trusted, totally verifiable source of high-purity feedstock, this system isn't just some cool business idea. It's basically a piece of strategic infrastructure. It helps lock in the region's position as a real leader in the next generation of industry. And that brings us right back to the founder, Mike Atkinson. This quote from the source material just nails the whole mission. The goal was never just to be a better bin company. The real goal is to use software to engineer certainty, to architect truth in an industry that's always been defined by chaos. So if there's one thing to take away from all this, it's this. 95 Wood isn't really a waste management company at its core. It's a technology company. Their product is a refined, data-rich version of the physical world. The bins, the trucks, that's all just the user interface. And that, of course, leaves us with one last big question to chew on. If you can build a digital refinery for scrap wood, what's next? What other messy, dirty industries, think about agriculture, mining, even textile recycling, are just sitting there waiting for someone to build a similar bridge from their chaotic reality to the clean, orderly world of digital assets?